So this is Chapter 3, Section 3, Graphing and Solving Systems of Linear Inequalities. The first thing we want to do is we want to talk about the quadrants. So I have 4 quadrants drawn up here. The upper right-hand corner quadrant, what quadrant is that? That's quadrant number 1. Thank you, Gonzaga. Appreciate that. At this point, all my other quadrants are in order, but I go in a counterclockwise fashion. So I have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And yes, we write them in Roman numerals. Why? Because we're math teachers and we're geeks this way. And so this is how we talk. Excuse me 1 second. Okay, so we're back and I've enlarged and changed the graph just a little bit, so make sure you pay attention and are aware of that. So here we go. What I want to do is I want to graph a system of linear inequalities. The first thing you want to do when you're graphing a system of linear inequalities is you want to pretend they're linear equations. So instead of thinking of this as y is greater than or equal to negative 3x minus 1, I want to think of this as y equals negative 3x minus 1. If I was going to graph that, what would I do first? Well, the first thing that I would do is I would graph my y-intercept, because my b would be the coordinate of 0, negative 1. And then I have a slope of negative 3 over 1. So I start at 0, negative 1. And my slope is down 3, right 1, down 3, right 1, or up 3, left 1, up 3, left 1. So now the question that I need to decide, is this going to be a solid line or a dashed line? If I look at this and I notice that I do have the equal sign here, so this needs to be a solid line. So I'm going to come up here and I'm going to get the black solid line, and I'm going to draw a black solid line through these points as best as I can. And I know, and I make it pass on both sides of my graph, saying that it goes on forever, and that's my graph. So now I need to decide, am I going to shade above this line, or am I going to shade below this line? I'm waiting for people in the class to actually answer, because they're not used to that. If it's greater than or equal to, what do I shade? I shade above this. Now, if you don't remember that I'm using black, so let's use black. If you don't remember to shade above, since it's greater than means above. If you don't remember that, you can always pick a point. And the easiest point to pick is the origin, 0, 0. If you plug in the point 0, 0, you get 0 is greater than or equal to, negative 3 times 0 is 0 minus 1. Is 0 greater than or equal to negative 1? Yes. So this is in the correct, this point here is in the correct region, so I want to shade this side of it. So this is the region that I want, and that's my first equation. I now need to graph my second equation. My second equation has a y-intercept of 0, 2, and a slope of 1 over 1, m and b. So I plot my point. That's kind of messy. Let's kind of clean that up a little bit. Why am I cleaning it up? You'll see in just a second. But notice that I do want to shade this, but I don't want it too messy. So here's my first region. My second region, let's go ahead. We started in blue, so let's do in blue. My y-intercept is the point 0, 2. My slope one is up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. At this point, I need to decide if this needs to be a solid line or a dashed line. Since there is no equals, it is just less than, I want to go ahead and make it a dashed line. So I'm going to pick this purple dashed line because that's the only dashed line I have up there. I'm going to draw in, and that's off a little bit, I know. I'm going to go ahead and I'm going to fix it. There's my dashed purple line. I need to decide, do I want above this line or below this line? Since this is less than, I want below. Again, I can always pick a test point, and the easiest test point is still 0, 0. So 0, is it less than 0 plus 2? Is 0 less than 2? Yes, so this is in my feasible region. Since I've been using blue, I want everything below this dashed line. Notice what I end up getting here. There's our lovely word notice again. I get a region that is shaded twice. This doubly shaded region is the answer to my inequality, because I want the area that is shaded. Since I'm working with a system, I want the area that is shaded by both of these. So my shaded region includes the solid line, does not include the dashed line, but then includes everything that's shaded with both. So all of this is the answer to my system of inequalities. So it could be any of those points in that shaded region, in the doubly shaded region. I do have a singly shaded region here and a singly shaded region up here, but those are not in both regions. Any point in both regions is a solution to my system. So there's another way to check this, and I need to make sure to check this. I want to check this by looking at my calculator. In my calculator, I can easily type in negative 3x minus 1 and x plus 2. What I need to figure out and decide is what type of calculator I have. If I have a TI-83, I can go ahead and just arrow over to the left of the y equals. If I look at this, I can now change this to greater than or less than. Get out your calculator so you can see this. I will pause so you can check it. I didn't need to pause. You could have paused me. So let's go ahead and do this. If I want to try this to make this greater than, like the first one is greater than or equal to, you're going to left arrow over so that on the left of the y equals, the cursor is flashing. You're going to hit enter once, and it's going to give you a fatter line. You're going to hit enter a second time, and it's going to shade the upper right-hand corner triangle. This stands for greater than. I'm going to go ahead and arrow down, and I'm going to do the same process. Hit enter once for a fat line, hit enter twice for a greater than, but I need to hit enter a third time, so now I get a less than. When I do it this way, the calculator will do greater than or less than. It will not do equal to. You have to do that part on your own by knowing if it's a solid or dashed line. But if I hit graph at this point, there's the first shading, there's the second shading, and notice I have a doubly shaded region. Okay? That's how I can see if I did this correctly. And if you look, assuming my scales were the same, it is the same shaded region. Now, if you have a TI-84, you possibly have a special application. Underneath, to the right of the math button, there's a button that says apps. Hit that now. At this point, you want to arrow down till you get to something called inequalities with a Z, inequalities. For me, it's a little bit down. It depends on your calculator what you have in here or don't have in here. But I can find inequalities. If you hit enter, it turns it on. If you hit it, if you go back to it, it will actually turn it off. And when I turn this on, look at the bottom here. I'm going to pull this to the side so you can see it. It lets you choose if you have equals, less than or equal to, greater than or equal to. So the calculator can actually do all of this for you. So if I bring up my calculator, my first one I want greater than or equal to, so I'm going to hit the graph button, which goes with greater than or equal to. And it gives me a solid line. I now need to go back to, that didn't work, hold on a sec. That should have worked. Hold the phone. Hit window, okay. Hold the phone, give me a second. Hit second graph, that didn't work. Pause. Okay, so to get these points that are underneath, that are above the y equals the windows, the zoom, the trace of the graph, you need to hit the alpha button, which is underneath the second button. The alpha button then gives me a little flashing A up there, and this first one I want greater than, so I'm going to hit the graph button, and it literally gives me a greater than or equal to sign. I'm going to arrow down, and for this one I need less than, so I'm going to hit alpha with the flashing A and hit window to give me the less than sign. And notice it gives me a less than sign. If I hit graph now, it gives me a solid line for the first one. And look for the second one, it actually gives me a dashed or dotted line. So the inequalities is a nice thing to have. If you have a TI-83, you probably don't have it, but a TI-84 will have it for you. So with all of that out of the way, let's go ahead and do another example. So graph the system. Let's go ahead and make these larger so that you can see them a little easier. X minus 2y is less than or equal to 3. Y is greater than 3x minus 4. There's lots of ways you can do this. You can put these in slope-intercept form and graph them. You can go ahead and put your cell phone away. Thank you, Mr. Rupp. Appreciate that. Or you can go ahead and use the intercept form to graph these. It's your choice. So I'm going to go ahead and put these in slope-intercept form and graph them. My first equation, to put it in slope-intercept form, this is a little big. I'm going to subtract x from both sides. So I get negative 2y is less than or equal to negative x plus 3. I'm then going to divide by a negative 2. Now, as the math teacher, I purposely chose this because whenever you divide by a negative number, what happens? I have to switch my sign. So y is going to be greater than or equal to, that's not a greater than, is going to be greater than or equal to 1/2 x minus 3/2. So I'm going to go ahead and graph this. For this problem, I start at my b, which is 0, negative 3/2, with a slope of 1/2. So negative 3/2, I'm going to go down 1.5. Up 1 to the right 2. Up 1 to the right 2 puts me halfway there. Up 1 to the right 2 puts me there. Up 1 to the right 2, up 1 to the right 2. Remember, I can also go down 1 to the left 2, down 1 to the left 2, and that gives me my line. I need to decide if this is a solid line or dashed line. It is a solid line since I do have equals. So I'm going to draw my line like this. And now I need to decide if I want to shade above this or below this. If I look at this, remember my new inequality here was greater than or equal to. So I want above this line. So I want all of this up here. My second equation is already in the form, so I know that my b is the point 0, negative 4. My slope is the point 3, 1. I start at -4, 1, 2, 3, 4. Up 3, 1, 2, 3, right 1. Up 3, 1, 2, 3, right 1. Up 3, 1, 2, 3, right 1. Up 3, right 1. I can go down 3, left 1. And again, I need to decide if this is a solid line or a dashed line. There is no equal, so I want a dashed line. The only one I have is the purple. So let's go ahead and draw my dashed line. Again, I need to ask the question, do I want above this or below this? I can always pick a point and choose, but since it is greater than again is above, so I want everything that is above this line, so I want all of this. Again, what you are looking for is the double shaded region, and the double shaded region, we'll do smiley faces this time, is along the dotted line to this point of intersection, and then I'm going to go along this line here, and then I want everything in between. This is the doubly shaded region, so these are all the points that I want over here. Remember that one line is dashed, one line is solid. All the smiley faces is my answer because that's my doubly shaded region. Let's go to our third example. In our third example, I'm going to throw in a wrench here. The wrench that I throw in is that I give you a third equation. Instead of having just two equations, I now have three equations. And with this, I'm actually going to create what's called a bounded region. A bounded region is an area that is closed off by a line on all sides. Three-sided figure, I'm going to be making a triangle in this particular one. This will lead to our next section of linear programming, which is what we will be doing on tonight's video, so make sure to watch the next video. So let's go ahead and look at what's going on here. I have three equations. I want to graph this inequality. X is greater than or equal to 0. That tells me I want all my x's that are greater than 0. I don't care what y is, but x is going to be greater than 0. So when I go to graph this, I'm actually graphing my y-axis. Because x equals 0 is a vertical line, and I want it to be at 0, so I have x is equal to 0. So I did x is equal to 0. Greater than or equal to 0 means I want all my x's that are greater than 0, so that means I want everything to the right of my y-axis. X equal to 0 is my y-axis. I want everything to the right of that. Y is greater than or equal to 0 is my next line. So I want essentially my x-axis. So let's go ahead and choose my red line. Again, I want a solid line because it does say equal. Make sure I do put it in the right place. And I want everything that is greater than this, so I want everything that is above this. Right now I have a doubly shaded region that takes up one of my entire quadrants. Which quadrant is doubly shaded? Quadrant 1. So I know my answer is just going to be in quadrant 1. To save myself a little strife later, I'm going to go ahead and erase that. I know my answer is going to be in quadrant 1. To save myself problems, I'm going to erase this. But you do want to shade. Since I have three equations, I'm going to have three shaded regions. And I want the region that is shaded all three times. So let's look at my last equation. Again, one of the simplest ways of doing this is to put this in slope-intercept form. 4x plus 3y is equal to 24. I can put it as equals because I'm just solving to find the line. Subtract 4x, 3y is equal to negative 4x plus 24. Divide by 3, y is equal to negative 4/3 x plus 8. So at this point, I can go ahead and graph this. I have a y-intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8. My slope is down 4, right 3, down 4, right 3, down 1, 2, 3, 4, right 3. I do have an equal sign, so I do want it to be a solid line. I'm going to use the solid blue line. And that's the line that I want right there. Since I am just looking at quadrant 1, I actually don't have to go much past that. And now I have to decide, remember this was always less than, less than, less than. So I want what's less than or below this line. So the triply shaded region that I end up actually gives me this triangle. Because I want what's to the right of the y-axis, I want what's above the x-axis, and I want what's below this blue line. So the triply shaded region is this triangle, and that's my answer. Since all of them are equal, all my lines are shaded, and this is the region that I have. Okay, last example. This is the same type of problem that we just did. So we just want to make sure that we've got a gist to this. Again, x less than 0 tells me that I want my x's that are less than, oh, let me use a different color, less than my y-axis. Y greater than or equal to 0 tells me I still want lines that are greater than my x-axis. So I want things that are to the left of the y-axis. And I want what is above my x-axis. So I notice that this is going to be in quadrant 2. Yes, I agree. I'm going to have more blue lines down here. And I'm going to have more red lines over here. But I did already know that I was going to be in quadrant 2, so I was focusing on quadrant 2. The last thing that I have to be careful of is my third equation. My third equation, x minus y is greater than or equal to negative 2. Solve for y, so I'm going to subtract x. Negative y is greater than or equal to negative x minus 2. Divide everything by a negative 1. When I divide by a negative number, I have to change my sign. So y is less than or equal to x plus 2. X plus 2 gives me a b of 0, 2, and a slope of 1 over 1. So 0, 2 starts here. Let's use a different color. Let's use green. And it goes up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. And I'm going to get this green line. It is a solid line since it is equal. Since I divided by a negative, I want what's below this. So my triply shaded region is actually this small green triangle right here. Again, all three of my equations have the equal sign, so all three lines are solid. All three lines are part of this, and that is my equation. That is my region. That is the answer to this. Have a great evening.